Hello and welcome everybody. In this video I will go over setting up the social interaction cloud, connecting your robot to it, and for this we'll also discuss the main components of the social interaction cloud and the communication that happens between the robot and the cloud. For this video I also assume you already installed the social interaction cloud on your laptop following the instructions on our wiki. And if you haven't done so, do so before continuing with this video. So before we really set it up, I think it's important to have a basic understanding of the main components of the social interaction cloud, so I will go over that first. So there are three main components. Of course, the robots and our cloud architecture and a client. And in our current setup, the client and the social interaction cloud are installed on the same machine. In the future, the social interaction cloud can also be installed on a remote server. And of course, clients can be computer applications, but it can also be a cloud application as well. Besides our own internal cloud, as it were, we can also use external services. And in our setup today, I will use Dialogflow by Google as an external services for automated speech recognition. So what's important to realize is that the processing power and the memory of the robot are not that great. So that's one of the main reasons why we migrated the processing of data to the cloud. So for now, basically what the robot does is it streams its audio that it receives through its microphones and its video data that it receives through its cameras to the cloud, and also all the events that are generated by the robot are also streamed to the cloud. And it receives actions, for example movements or commands for its text-to-speech engine so that it can say stuff, but it can also receive audio that it can play through its speakers, and this is the way the robot is controlled. And it's the client's job to be basically function as the brain of the robot. So given all the data coming from the robot, decisions can be made. The logic that is embedded in the client's code, and it generates actions, or the client can send actions via the cloud to the robot. It's also the way for the cloud is also the gateway for the external services. So for example, if part of your interaction there is some speech recognition necessary, so the client sends out the speech recognition requests, the server, the social interaction cloud actually calls the external services, in this case of Dialogflow, and parses the results and send them back to the client that can then make decisions based on that data. Given this basic overview, it's time to actually set it up. So what is important is that Docker is running, and if Docker is running, then we can go ahead. So in part of the installation instructions is also the instructions to install Git, and Git comes, Git for Windows at least, comes with a nice terminal interface, which I will be using for this demonstration. So I open a terminal, I navigate to the Docker repository that I cloned from our Bitbucket. So you can see the Bitbucket has a repository Docker, which is part of the installation instructions to download this here. And all the code and all the stuff to really start up the cloud infrastructure is in that repository. So the command to start is docker compose up, and then followed by the services you might need. And in this example, I only need the Dialogflow service. So this is my start command, and you see that the necessary Docker container items are created, and we will be subscribed to the Dialogflow services as we know now. So now that this is started up, I open a new terminal because this one is currently busy. So notice that I didn't use the -d flag because I want to output here. So the output that we will show here are basically speech recognition results, which are interesting when developing. If stuff goes wrong, you can see if the robot misheard or nothing was recognized, or also if it goes correctly, you can see the speech recognition results show up here, which we will be looking up later. So now I opened a new terminal with the purpose of connecting our robot that I booted up to the cloud. And the important thing here is that we will be using the robot installer, which installs the necessary Python scripts onto the robot for connecting with the cloud. So that is also installed in the Docker repository, so I will go there. And specifically, it's installed in the CBSR local folder inside your Docker repository. There are multiple ways to start it. Some are explained here. You can also use double-click the robot run installer, or double-click the robot installer itself. I'm using it via the Java jar command to start it. And what now happens is that we see this connection screen. And it's important here, depending on if you used the Docker toolbox or the Docker desktop, which IP address is relevant here. I used the Docker desktop, so the default local host IP address is fine. So I will use this, and the username and password are disabled at this point, might be enabled in the future, but for now we can just enter the server address here and click OK. So what now opens is the CBSR robot control screen, which allows us to connect to the robot. So if we hit connect, then we get this connection screen where we need the IP address of the robot and the password. And the password defaults for the now robot is now, and the default password for Pepper is Pepper. So I will now quickly show you how to figure out the IP address of the robot. You can simply do that by pressing the button on its stomach.
Hello, and now my internet address is 192, 168, 178, 35.
And there you have it. Then it says its IP address, and we will verify what's being said here. Yes, that's the IP address just being iterated by the robot, and we can use it to connect to the robot. So the following screen opens here, and because the robot is connected to my Wi-Fi here and my laptop as well, so I want my Wi-Fi network interface selected here, because that's the way my laptop and hence the server are connected to the robot. So now the scripts that are needed to stream audio and video and send commands and execute commands on the robot are installed. It uses Python. They are Python 2.7 scripts, because that's the only version of Python that is currently stable for the now. I'm not sure, and probably they will not upgrade it anymore because they're moving on from Python, I believe. But for now, the versions of the robot that we are using still uses Python 2.7. So the warnings you get here, they are to be expected, and you can just ignore them for now. Following, you see that a lot of required packages are installed. In my case, they are already installed, so they just say it's already up to date. It might be as well for your now, but you might have a now where these packages still need to be installed, so this process might take a little bit longer. So what we see here are a number of tabs that are basically the output screens for the different scripts that are running on the robot. So starting with the event producer, it shows the events that are triggered or produced by the robot. Let me quickly demonstrate that. If I press the head button of the robot, you will see the events of the pressed and touched, or the touched and released events shown on the screen. Simultaneously, to demonstrate the other tabs, I will run a quick example script that's also available, and you can find example scripts in the connectors repository, which we recommend you download and not clone, because you will edit stuff in here which you don't want to push to this repository. So if you are on the connectors repository page, you can simply hit download and then download repository, which I already did. And I opened the speech recognition example, which I will address in the video on this specific example. So if you want to learn more about this script specifically, I will recommend you watch that video. But for now, I will just simply run it.
Hi, I am now. What is your name?
Hi, my name is Mike.
Nice to meet you, Mike.
Alright, so we've run this script, and important to notice is that we use speech recognition. So let's see if we have a result. Yes, you can see here the transcript of what I said. Hi, my name is Mike. We successfully recognized a name. What this all means I will discuss in the video about speech recognition, but for now it's important to notice that indeed it recognized my name Mike, and it parsed it along. So that output you can find at the place where you have started your the Docker Compose up command and the service dialog flow in this case. So going back to the robot control, we see a lot of things happening in the event. So a lot of events were triggered. For example, we noticed the robot standing up. It became in an awake state. Its stiffness changed because if it's in the rest mode, you can move the joints freely, and if it's active, the stiffness increases and the joints cannot be moved freely. Only the robot can control the joints in that state. And at the end, we see that the robot is going back to the rest mode, and indeed the body stiffness is reduced back to 0. So the robot greeted us. Text-to-speech actions are also considered audio in this case. So first it changes language to English. The robots have by default a Dutch and an English language settings available, and then it made the remark, hi, I'm now, what's your name? And nice to meet you, Mike. So 2 say actions, which also correspond in the event producer tab with text started when the robot is started with its speech, and text done when the robot is done saying the sentence that it was sent. And it also produced audio, my speech it recorded with its microphones, and it streamed it to Google's Dialogflow. We see here that it streamed audio for 3 seconds before receiving the stop command. The other 2 tabs, the tablet is not applicable for the now because it doesn't have a tablet, and the video producer is empty so far because we didn't produce any videos. The cameras were not turned on for this example, but if it were, if you need the cameras for something, then the output will be shown here as well. All right, now that we are done with our interaction and we're done for the day, we can simply disconnect with the robot, and we can hit Ctrl+C to stop Dialogflow from running, and we can hit the Docker compose down command to really close down our Docker container for this application. And that concludes it for this video. So there will be other videos on how to create your client code, and one specifically discussing the speech recognition example. So thank you for your attention, and see you in the next video.